We are installing a satellite computer connection.
We spent basically, from dawn to dusk and even further on in the village setting up the computer.
Not only have they not used a computer before, they've never seen a computer before in many of the cases, literally. We asked them.
As far as we know, the telecommunications professors there told us that this is the first primary school in Tanzania that has internet access.
They had heard about what a computer is. Most of them hadn't really seen a computer.
We went out to a primary school in a very rural region of Tanzania.
The reason we chose Tanzania was because we were looking for a good place that would test out a computer, under rugged environmental conditions.
It's another thing to actually go to Africa and just see it firsthand and to have to deal with the challenges.
Not only is MSU learning about the physical aspects of the computer and, does it really work in these rugged conditions and things like that, but also it's a real learning experience for Tanzania.
This gives them an opportunity to see the rest of the world.
Sparty at the Detroit airport.
That's right.
The idea was we'd take a succession of our student teams,
Sparty aboard flight
6:15
to Amsterdam.
let them design systems, and then we would take them actually to, in this case, Tanzania,
Here we are at the airport, trying to fly to Arusha.
and try them out in a school and see what lessons we learned.
There's our telecom professor, trying to get some signal, make a phone call. We suggested he stand next to the satellite dish.
It's a really fun project.
We really wanted to be on this project from the beginning.
As a university, we've got a bunch of bright young students that can get involved in projects like this.
When we went there, it was not what I expected.
163 centimeters.
The group that actually went to Tanzania was myself and a telecommunications professor, Jennifer Olson, who went to the village with us. Professor Kurt Dimaj went along to Dar es Salaam. And with us, we took 4 students from electrical and computer engineering. We joined up with 2 students who had also been working with us at long distance from the University of Dar es Salaam. These were both electrical engineering students. And with 2 of their professors, a telecommunications professor and a power systems professor. And so there actually was a group of 10 of us that went to the village, the Lasirwa village, where the Baraka primary school that we worked in is located.
And once we finally got to the village where we were installing the school, the students were just really happy that we were there.
Spent each day and several nights at the school working on putting all of the gear together.
Are you done inside?
No.
I'm going to double click the calculator. That brings up the calculator.
It's hot, extremely hot, it's extremely dusty.
About a year ago, we talked to a company called Lenovo, and they're the people who build the ThinkPad computers. They were interested in working with us on trying to develop a computer system that could be used in remote locations. For example, in an African village where there isn't a power grid, but they still want to provide connectivity to the internet and so forth.
We designed a computer system with a solar power.
Underneath there, we got the wires.
So that it could be deployed off-grid, which the school that we put it on didn't have access to power. It didn't have access to water.
Definitely out of the way, no power grid, no telecommunications infrastructure, off any sort of major road.
And that's another part of engineering, is being able to figure out how to, right, with what you have, how do you make something that's going to do the job?
Crawl under here and install the nuts and bolts so these things don't fall off.
We gave them a rather abstract set of specifications and said, go for it. They designed something, they came along with us, they did most of the implementation work. And so it's a student-led project to deploy satellite solar-powered internet computers in a rural school.
240 volt power inverter.
The project is to develop a computer system that is cheap, so that it can be deployed in third world countries to give students access to the internet and to learning materials. Books are expensive, paper is expensive, pencils are expensive.
And as it turned out, it was an excellent place to do it because people were so excited to have this computer in their classroom.
Here we have computers and books and paper and all the resources we need to learn to the best of our ability. And they do the best they can, but they don't have the resources that would help it. And so this is a huge step.
Who knows where the drill is?
The drill.
The headmaster of the school and the teachers had basically given us one room of the school that was devoted to this, which was a terrific thing because that way, you know, the students could be working there and they wouldn't be disturbed by classroom activity.
They designed what they were going to do in advance, but much of it could not be fabricated until we actually got to Tanzania. When we get there, some of the components are hard to find. Do we know what this diameter is?
This diameter we are not. No, you don't.
Let's measure that.
Could be about.
Looks like 4.
So basically the idea is that we want to provide them with sort of the equivalent of a digital library in this region, but because of the complete and utter lack of infrastructure, we kind of had to take all the infrastructure with us. So we had to bring the satellites, the power, the computer, everything along.
If we burn out a printed circuit board that we built, we've got no capability of building another one. So what do? You bring spares.
And you have to have a backup plan, and you have to have 3 backup plans for your backup plan.
We've got these big wires we've got to crimp, handling the solar power so we don't lose too much power in the wire. We took a crimping tool with us to Africa because we didn't know whether we'd be able to get it there or not. Many of the hardware stores there are kind of a little mom and pop shop by the side of the road. There's no Home Depot.
Rather comically, there was a shop called Home Depot that we were driving past. I think they were just playing off the American name. It definitely did not look like a gigantic construction supply store.
I'm too far.
Kids from the village were around. And they were, of course, they were
The
fascinated.
students were just really happy that we were there.
And they quizzed our students on math problems on the blackboard.
Wanted to play with us.
Our students played a little soccer with
They were
them.
just all so happy, you know.
They didn't have a real soccer ball.
Like instead of a soccer ball, they have a ball of rags.
We're sure going to take care of that next time we go back.
They were watching the whole time.
One of the students brought a little handheld video game on his cell phone.
Yeah, they jumped right on that. Most people there had never seen an iPhone or even heard of an iPhone.
And he started passing it around to the students. They were just sitting around outside the school as we were working. And I mean, they'd never had a chance to do that before. And it's fun. I mean, they were just delighted.
I was watching the kids and how excited they got more than the game. But the amazing thing was he showed them, and before he could even explain it to them how to do it, they had figured it out, and they wanted to try it, and immediately they figured out how to do
They
it.
were all really willing to pick up the technology. They want to learn how to use it.
The Tanzanian school kids also helped, they helped digging trenches to put the conduit in, to communicate with the satellite, and just whatever they could do.
I came here and learned about the efforts to set up this solar-powered internet enabled rugged PC. It seemed like a wonderful opportunity.
It's a project where we're trying to do some research, trying to gather data, collect information on the overall impacts, the social impacts. Also to give the students an experience. It's a wonderful experience for them to get out and hopefully deploy wonderful new technology solutions that they are developing.
The students also have to learn how to build things that are going to work reliably, because they're not going to be right there to take care of it. And they had to think about how do you design something so that it's not complicated and you don't need a master's degree to run it.
Well, the team had been working on some of the wiring things that they could do.
It's a great opportunity for them because it's a very hands-on project, so they actually get to use what they've learned in the school.
The students that went on this trip did not come home feeling like they went to Tanzania as tourists. They did not. We spent 4 hours touring and the rest of the time working. That's a much better experience than to go and spend a few weeks touring, frankly. It's just much more inspiring. In some sense, it's very much like a study abroad experience.
Oh, incoming.
Except that instead of going and more or less passively studying something, they're going and actively doing something, and they're working with technology that they've already been developing. So it's you get a different feeling in a country when you go in and cooperate and collaborate with people and work with people from that culture, as opposed to simply going and sitting in a classroom and learning.
The collaboration was a perfect example of all these sort of loose, casual links you make over time, suddenly all just coming together in a crazy moment.
Nafikiri pale ndio pazuri kama
A lot of complementarities in terms of what we're doing, because, you know, on the one hand you think, satellite solar-powered computers in you know, Tanzania, well, that's really an engineering problem. Well, yes, of course, there's a lot of engineering problems, some great challenges there. But once you actually have that hardware installed there, you need some sort of services to deliver on that particular platform. Otherwise, you've just, you know, delivered a multi-$1,000 pile of, you know, silicon and metal. This really is sort of the ultimate multidisciplinary project, where it seems like half the university is starting to get involved in it, just pooling together the variety of different resources.
It's a pretty good environment for solar power.
This one is totally off the edge of the frame.
We're only 3 degrees south of the equator, so the days stay about the same length, and there's lots of bright sun, and it's right overhead for lots of the time. So our solar panels pick up a lot of energy in that way.
Got the solar panels up and running.
So we got 6 solar panels. They generate about 80 watts each,
Did you put washers?
and put them in a frame on the roof of the school. We had students, and even I was climbing around on the roof of the school. At the heart of the system is a Lenovo computer.
Put the monitors and got everything situated the way we wanted it.
In that computer, we put 2 dual-port video cards, so we could actually plug 4 displays into that one computer. That's in order that we could essentially run 4 seats for students to use, but with only having to power one computer to do that, and that cuts down on the amount of solar power that we need, of course.
You can imagine a project like that requires, you know, a pretty big toolkit.
We had to run conduits
We'll join them right up here at this corner.
from the satellite and from the solar panels down into a big control panel, essentially.
We actually ended up spending about like a 14-hour day straight actually doing the final install.
We were there one morning, for example, we were working in the school until 3 o'clock in the morning. And then we were back up and at him at 6:30 in the morning after that, because we had to. I mean, we had to get it done.
Yeah, and I'm gonna go.
Expanded to that, right?
Yeah.
This roof is like a radiator. Radiates coolness.
If your deviation is all south, no east-west. The students realized we had this nice steel cabinet that housed all of these components, the computer and the power stuff, and it was painted green. And we thought, well, you know, really, I mean, here's this green painted surface. It needs a block S. So we got some white paint and made a quick stencil and painted a block S on it, just again to try and strengthen the connection. But that's got 3 compartments in it, and everything in that had to be wired up. The solar power system and the computer communication system and the satellite internet and all that had to be essentially put together and tested and installed on the spot, with conduits running up to the roof, and conduit running to the satellite antenna beside the school building, and then cables running out to the terminals on the tables and all those sorts of things. So
9 amps.
we put a kind of a wood divider in the middle of it, in a back compartment where we have all the high voltage stuff that you don't ever want anybody touching. And so that's sealed off, and it's locked. And then in the front, you have a panel, the front of that panel, where you have then all the controls, the switches, circuit breakers, things like that for powering on the computer. That plugs into a satellite, and the satellite communication is via a dish that was mounted on a pole outside the school building, and of course we had to pour concrete to set that pole in because it's got to stay pointed in the same direction at that satellite. It's pretty sensitive.
I would say one of the biggest parts of the project was sourcing the things that we needed.
Down at the bottom are 2 monster batteries because we need to be able to run the system, of course, not only when the sun is shining brightly, but also some of the time and we're aiming it up to 4 hours when there isn't good sunshine. Tanzania has a rainy season.
It was a pretty crazy hectic day. There was a lot of wiring to be done.
Well, right now we're getting ready to test the system.
But once we got it all together, it all worked on the first try. It was a pretty amazing experience.
It's not just that it's the internet per se, but it's that it's information. Because this school, like most schools, hardly have any books at all. So any kind of information is just, I mean, people are thirsty for information.
We have a lot of educational games and things installed that help them to learn to use simple things like a mouse, because it seems like second nature to us, but like really that's the first step to learning a computer.
I mean, the teachers had never seen a mouse before, but they caught on almost, within 5 minutes.
They're really excited about it, and they're really excited to learn, so it'll be exciting to see when we go back.
And that's a long-term development educational thing for Tanzania, and we can take those lessons and apply them elsewhere. So that's really, really critical.
We hope that ultimately we'll learn things that will be valuable to Lenovo as they look to actually create a real-world product.
Well, when we did the training of how to use Wikipedia for the teachers, they just, I mean, we could hardly get them away from it.
Of course, educating the local teachers to make sure that the teachers know how to use the technology, make sure the teachers can integrate the technology into their classroom.
A delightful surprise to me. They called me up and Professor Olson and gave us the traditional garb that they wear, and then they gave me it's a sort of a club that's called a rungu, and it's something that elders are allowed to carry, others can't. And they made me an honorary elder of their group. When you get older in that country, you get more respect, not less respect. It was very moving that they wanted to have us feel like we were a part of their community.
3 keys to the 3 compartments on that large metal box here, and with these keys go responsibility.
Well, we wanted to essentially turn the keys to the system over to the village, letting them understand that it's theirs.
And so it's an experiment, to see what works, what doesn't work, what the teachers and the students get the most out of the internet and of the computer.
It may be a first, at least it's an early pioneering system in a Maasai village, in a village where they don't have electric power.
This is actually an opportunity where you get out there and you're really doing something concrete.
For our students, of course, this represents an opportunity to work on something with a real customer, with real users in a school in Tanzania, and learn to do something that is very exciting.
Other students might have just read about, the problems, but I've actually gone there and I have successfully addressed these challenges. And I think that's a really compelling story to be able to tell to potential future employers.
The student teams are very highly motivated. They say, I don't care how much we have to work on this, we're going to make it work.
It's right here.
And it's an international project, so it reflects the sort of increasingly global nature of all jobs, so it gives them a global experience. It's not just the challenge of the initial deployment, but there's also then this next challenge, which we're really struggling with right now, which is to figure out how we can actually support, maintain, and extract value out of this.
They came back very much committed to continuing their involvement. 2 of these students have already graduated. Well, I had a meeting in my office yesterday with one of them, who was up here on campus, figuring out what do we want to do to improve the software in that computer there. He's dedicated to seeing that happen, even though he's already, he not only is not getting a grade, but he's not even at MSU any longer.
It really is great. There's a lot of work that still needs to be done. Obviously, the system needs to be, maybe a little more intuitive. The culture itself needs to become more comfortable with the technology before they can use it to its fullest degree.
I think the long-term impacts are pretty interesting, pretty exciting.
We think we are blazing some new ground there.
I almost think it's sort of the ideal buzzword project for what the university's overall mission is today.
Long-term, I think it's this partnership that's going to have a big impact.
But I think eventually it will be a much more open world for them to see.